Well, hello and welcome, Math 1. Mr. Robinson back here with yet another brand new exciting video. And it's Friday, baby. And guess what we do on Friday? We do Mr. Robinson's Q&A Power Hour. And here, I hope it's not an hour long. The intent is for it to be an hour long between my Math 1 and Applied Math. My Week 1 video was combined for both courses, but this one's specifically for Math 1. Afterward, I'm going to record one for Applied Math. You guys asked a good set of questions. Applied Math has a good set of questions. And I'll generally keep them separate as long as it's like that. If you only ask a few questions, I'll probably combine it with the other one, and you'll be none the wiser. Now, how do you ask a question? How do you see the answers to the questions, and how does this benefit you in the long run? Well, it's really quite simple here. If we go ahead and look here at, well, there are the questions here on the left side, but on the right side, if we look at my portal, I'm going to go ahead to Google Classroom. Within Google Classroom, you find my class. I'll go ahead and find one of our Math 1 classes. Let's go to Math 1 4th period, and under classwork, you can find headers. Within the header, Mr. Robinson's Q&A Power Hour, you'll be able to see a few things here. You'll probably see 4 items. By the time you click this video, you'll probably see a Week 2 item. There's Week 1 and Week 0 right here, which have the previous questions that were asked in Week 0 if you look at the timestamps there, and the videos down below. Within the video, you will also see the timestamps for the questions that were asked, and they are clickable if you are on a computer. Week 1, you can see the questions right here as well, with Math 1 content and some miscellaneous questions that were asked. Questions are asked and answered in the order that they're received. But of course, they might jump around based on whether I do a Math 1 thing, then a general thing, and back and forth. So make sure you look at the timestamps within the video itself, and you'll be okay. Now, once you see that you still have a question that wasn't asked and answered on these, and probably wasn't asked and answered in, say, a daily bulletin, or a how-to video, or of course, just within the descriptions of each assignment itself, then you go to the submission form, question submission form, which is of course closed until Tuesday, May 5th, because that's when Week 3 material opens again, and I close the questions here because these are the questions I already took. So they're closed until Tuesday, and they'll be re-uploaded again, or it'll be re-enabled again for you to resubmit questions. You go to the Google form, you submit a question, and then I go ahead and answer it. But again, try and ask a question that hasn't been asked and answered before, because if it has, I'll probably just say go to a previous video. We don't need to waste each other's time to make that thing happen for me to say something I've already mentioned. If you're asking something slightly different than before, maybe I'll go ahead and answer it. I haven't really looked at these questions in great detail, so let's just go ahead and look at what's being asked and see how I can fumble around and answer them for you here. So let's start off with the first question here, and the first question that is asked is, can you see our progress on Khan Academy? The simple answer is yes, I can. So I can see how much you have done when it comes to which topics you've done, how much you've attempted, when you completed it, things like that. I don't know if I can see mid-progress. So if you've only done 2 of 4 questions, I don't know if it shows that part. I don't think that really much matters. I don't want to monitor progress live. I want to check it when I'm grading it. And I'll be able to see that for you at that time. So you don't have to tell me when you finish something. Once you completed a task and you got, say, 3 out of 4, I'll know about it. I could show you spreadsheets and stuff, but I don't want to reveal names of students, who's done it, who hasn't, what their score was. But believe me when I say that I can. I can indeed. All right, so with that down, let's go to the next question here. When we find x, do we substitute it for the equation that we are trying to solve for? So if you were in applied math, this might apply to systems of equations, but this wasn't an applied math question because you have a different... you would have accessed this differently for being a Math 1 student. So if this is Math 1 based, I'm trying to think what this has to do with, because in Week 2, we definitely don't have even though you solve for x in an angle, you find a missing angle, that's all you do with it. Once you find x, you found the angle, so there's nothing to substitute for. If it's based on Week 1 material, let me go to the stuff that we have here. If it's based on Week 1 material, the only place that I can see it apply, let's go to an assignment, is... I think when we had the segment edition, so let me scroll down to these old ones here. Segment edition video, practice. So if I go to the practice here on segment edition, let's take a look at this problem. I'm not going to go through it, like write it down. Let's just walk through what it says here. So you have 2 segments of unknown lengths. The whole thing is 69 units long, but JT itself is 3x plus 5, and CJ itself is 4x plus 8. So you use that information to solve for x, 4x plus 8, plus 3x plus 5 equals 69. Let's see, 7x plus 13 is 69, subtract 56. So x equals 8. So when you get x equals 8, they don't say solve for x, they say find JT. But solving for x helps us find jt because this is the equation that we substitute x in to solve for. So yeah, once we find x, do we substitute for the equation we're trying to solve for? Yeah. 3 times 8, substitute it, is 24, plus 5 is 29. So I would know that this answer right here is 29 for this particular one, and then it's all squared away. So you substitute x in that particular case to solve for, and there's no other place that we really substitute after we solve for x. And that's the thing that I'm having trouble coming up with when answering this question. It depends on the problem. If you're only trying to solve for x and you're done, then you're done. But if you got to use it for more information, of course, yeah, you use that to solve for stuff later. If you're talking about segment addition, that's the only place I can think about it, and I hope I answered your question. Just guys, make sure that you're very specific when it comes to this because it's hard for me to tell what your question is asking. And keep in mind, this is week 2. This is week 2, and I'm really hoping for content-based stuff on week 2. If you have week 1 stuff, you know, it's a little antiquated, you know, it's a little bit outdated there, but hopefully I did answer your question along the way. All right, with that one down, let's go to the next question. And the next question is, how do you find the measure of an angle? Now, this might also be week 1. Let's go back to this one more time. How do you find the measure of an angle? Now, I don't know if I answered this before. I'm just saying I think it's based on week 1 material. Vertical angles, angle relationships. Well, it depends on what you're referring to because we are finding measures of angles with the complementary and supplementary things. So let's talk about this in a few forms here. Estimate angle measures. So this was a week 1 based thing right here, estimating angle measures. Let's just look at a couple of these very briefly. Let me call some things out here with it. Okay, this particular angle, I can't tell you exactly what the angle measure is outside of them asking you to estimate based on multiple choice. What I could tell you is this is around 90 degrees because as you may know, 90 degrees is a right angle. A right angle meaning, you know, like this, something, you know, that part of a square, a corner of a square or a wall or something like that. That's 90 degrees right there. Now, this is very close to 90 degrees on that. And, you know, degrees go from 0 to 90. Hopefully you can see on me to 180, and a full circle is 360. So this one's around 90 degrees right here in this particular problem. So I'm going to say it's clearly not 45. That would be half of a 90 degree angle. This is what's called an obtuse angle, leaning toward 180. This is called a convex angle, which almost does a full circle. You'd see the arc go around, say, more that way. So this one's going to be 95. So as far as measuring angles with that, you don't have to use what's called a protractor to actually get that particular measure. This is probably 30 degrees. It's not quite small enough to be 5. 5 is near crunching right toward nothingness. So 30 compared to the other ones looks good. That's how you measure those angles. But if you're asking about how do you determine an angle measurement based on complementary, supplementary, let's talk about that in a little more detail. So let me make sure I see all the different topics we have here and cover them. We have complementary and supplementary angles, and we have vertical angles. And then we have angles with parallel lines and transversals. All right, so let's break this down in a few different ways, guys. And to do this here, let me find my right, there we go. And to do this here, I want to, time out. To do this one here, I want to go ahead and draw some things for you. So let's go ahead and start with a set of complementary angles. I'm just going to go ahead and write comp right here. So here's a breakdown of complementary and supplementary. Number 1, we are referring to angle pairs. A single angle is never complementary. Okay, a single angle is not complementary. One angle pair can be complementary. So 2 angles can be complementary to each other. Now, what does complementary angles mean? It means angle pairs that add up to 90 degrees. Okay. Now, they do not have to be next to each other. They do not have to be adjacent and actually make a 90 degree angle to be complementary. They just have to add up to 90 degrees. But in this particular case, let's say I have a right angle right here, and I'll split it apart like that. And then I have one angle measure that's 50 degrees right here, and I don't know this one. I'm going to solve for that by saying if these add up to 90, then I know that when I add these up, I get 90. And you can solve it algebraically for there. Subtract 50 from both sides, you get x equals 40. So the complementary angle to 50 degrees is 40 degrees. And you might not have the drawing for them. And I'm not saying you'd have to draw them. The drawing kind of makes it a little more obvious. But again, they don't even have to be next to each other to be complementary. 50's angle complement is 40. Those are the ones that add to 90. So that's what complementary angles are. They're angle pairs that add up to 90 degrees. Not a single angle is complementary. Just remember that, because sometimes people say a right angle is complementary. It's not what it means. Now, complementary in the more English sense has to do with things that go together, like milk and cereal, things like that. Something that helps make something whole. I don't think that really matters for what you're talking about here. Now, that was complementary. Supplementary, I'm just going to put what's up? Supplementary are angle pairs that add up to 180 degrees. They make a linear pair of sorts. They would make a straight angle, if you will. Do they have to be made from a straight angle to be supplementary? No, they could be far apart from each other and still be considered supplementary. We're going to see instances of that when I still answer this question. So let's say I split off the angles like that, and let's say we know that this angle here is 45 degrees, and we need to figure out angle x right here. Well, if they add to 180, once again, same thing as last time, add up your two angles to 180, and go ahead, I'll subtract 45 from both sides and solve for x. I'll get x equals 135 degrees right there. So 45's angle supplement is 135. Those two add to 180. 90 and 90 add to 180 as well. Two right angles are supplementary to each other. And again, they don't have to be next to each other to be considered supplementary. They just have to add to 180. Can you have triplets be supplementary? It's not called that. Just angle pairs. Just angle pairs. All right, so that's complementary and supplementary. Vertical angles, pretty obvious or pretty easy thing to talk about. I'm not going to say, let's make these very distinct. I'm not going to say too much about it here other than the fact that as long as you have straight lines that form and make an intersection right here, then this angle will have an equal measure to this angle. I'm trying to avoid a certain word, congruent, because we haven't really learned it yet. And this angle here will be equal in measure to this angle right here as well. Angles that are opposite of each other when two lines are formed. It's kind of an obvious trait when you make lines that it just naturally occurs that way. Think of roads on a street map. If they're going straight, that kind of thing will happen with the angles that are formed. So, if this thing's 120 degrees, then this one's also 120 degrees opposite it, things like that. I know that on the vertical angles practice stuff, they ask you is something more or less or equal to it. These would clearly be equal to each other, but sometimes you see some angle sets where, it clearly isn't made from straight lines, so maybe you have something like this here. So those aren't straight lines here, so if this was known to be, say, 80 degrees, I would know that this one is less than 80 degrees because it's more acute than it, and in vertical angles, they're only equal if they're made from straight lines. So that's kind of the vertical angle talk right there. That's what vertical angles are. And I don't really know how to remember vertical angles this way, but if you think about them being up and down from each other like that, vertical angles. So I don't know where the name comes from, maybe from that, but of course these are horizontal angles. I don't know, they're all vertical angles there. All right, the last one I'm going to talk about right here. I don't know how much Khan gets into his video. I didn't actually watch it for it. I just answered the questions. But here's something that it could really be explored a lot deeper, and I'm sure we're going to at some point, but we don't get to as a class anymore. It's really all based on Khan and such. But if you have parallel lines, I should have drawn the parallel lines first only. I'm going to draw these little arrows to indicate these two sets of lines are parallel. Parallel lines means they never intersect. If they went forever, they would have the same kind of slope. I think we know that. When parallel lines are cut by what's called a transversal, meaning another line that's on the same plane, but not parallel, it intersects with it, it forms these distinct relationships here, and I want you to take a look at them and see if they make sense. I'm going to try and color code them and mark them as such. If I have this angle right here, this angle is also congruent to it because they are equal measure. I shouldn't say the word congruent yet. They're equal measures because they're vertical angles. That has nothing to do with these lines being parallel, by the way. These are just vertical angles, as you just last saw. Now, there is an angle set that are called corresponding angles, and it has to do with this angle right here and this angle right here. These two angles correspond to each other. They are the exact same angle measurement. Think about it. This line never breaks its direction. It's still the exact same direction it's always gone. And these two lines are parallel. Ideally, what you're looking at is just taking this one line right here and just moving it. Hang on. Taking this one line right here. I can't really get the angle with it. Take this one line, one more time, right here, and moving it right next to that one right there. See, it has to be the same angle that's being formed because I'm literally dragging it with it. So there's no way that it's not the same angle. Those are called corresponding angles. And again, I don't know if Khan covers the names of them. These are called corresponding angles there. All of these are equal in measure. And then if those two are equal, then that means by vertical angles, these two are equal as well. So when they ask, how do you find angle measures? How do you find the measure of angle? And I know I'm spending a long time on this problem, or this question, because I want to make sure, because I don't know how it's being asked. So I want to cover all bases for it. So how do you find an angle measure? If I knew that this thing right here was, say, 75 degrees, then I know all these other ones are also 75 degrees. They won't ask you with just with all of them. They just ask you with one of them. They say, hey, find x, and it's 75. Or if it's a corresponding angle pair, find x at 75. Or these ones right here, find x. These are called alternate exterior angles with each other. And again, I'm only saying this phrase if Khan said it. If he hadn't, maybe don't have to remember that for any particular reason. But just look at them. If you look at them, they look equal. They look equal. And I'm going to tell you right now, all angle pairs in this set are either going to be congruent to each other, which means equal angle measurements, equal size and shape. They're either going to be congruent or they're going to be supplementary. Now, where are the supplementary angles in these sets? Let's go ahead and take a look here. Supplementary angles, let's look at, say, this linear pair right here. This angle with this angle right here, as they're adjacent to each other, they make a straight angle together. These two are supplementary to each other. They add to 180. These two down here are supplementary to each other as well. They add to 180. And because these two are equal, that will make these two, well, these are vertical angles as well. So they're vertical angles, and they do all the same stuff here. So all angle sets in here are either congruent to each other or they're supplementary to each other, meaning they're either equal or they add up to 180. And there are all these different names for it. If you're talking about these two angles right here, these are called same side interior angles. If you talk about X and Y like that, these are corresponding angles. These are called alternate interior angles. And I'm not going to go over why they are that, but try and think about how the names are said. Corresponding angles are again same side interior, already said. Same side exterior angles, alternate exterior angles, and then vertical angles and linear pair, for example. So those are all the different kind of names that you'd see, but either they're equal or they add to 180. So how do you find the measure of an angle? Because you're not actually measuring this time. What's going to happen is they're going to give you an angle measure. So let's say they gave you that this thing here was 75. Once again, I can go ahead and then say that this same side exterior angle is going to be supplementary to it. And they look supplementary because this 75 is the same as that 75, and that's a linear pair. So I'd say these add up to 180, and then I'd go ahead and subtract 75, and I get x equals 105. So that's how you find that angle measure there. Okay, I think I've covered all the different angle measure things that you had, either if it's actually literally estimating the angle measure, complementary angles, supplementary angles, vertical angles, and parallel lines cut by transversals. You can see that they either add to 90, they add to 180, they're equal, or you estimate based on multiple choice and see which one is it closest to as far as being acute, right, obtuse, straight, or convex, which means it's going more than 180, like that. Okay. All right, so that covers all of those, and with that down, I'd very happily like to go on to the next question with you guys here. And the next question that's being asked is, hi, Mr. Robinson, I have a question. I turned in my homework to you, but I have an F. Okay, well, it sounds more like a personal question here, but it might apply to you with that. Now, no grades have yet been entered for the fourth quarter, so it shouldn't have to do with that. If you see an F for this quarter, nothing's been entered, so you're okay there. If you're talking about your overall grade, then that means it has to do with the third quarter. So all your homework assignments, if you remember based on the syllabus, homework accounts for 10% of your grade. Quizzes account for 30, and exams account for 60. That means that 90% of your grade is based on assessments. So if you turn in all your homework and you do poorly on assessments, it's possible that your grade is lower. Likewise, if your grade could be higher based on things. Now, I'll let you know right now, I've given a lot of leeway for people in Q3. You'll see some grace, some homework grace and test grace and quiz grace points. Those are free points I gave you for third quarter because you have an opportunity to do things such as exam makeups or something like that, and because you got graded on the late end of things because we were already on our break. Okay, so I gave you grace periods for that. I also gave anyone on the most recent test who got under 50%, 50%. So you did luck out in some certain ways there. So nothing's going to be changed to third quarter grades unless there's an error. But as far as raising grade stuff, that ain't going to happen. Now, as far as grades in general, some people might have a question on this, so I just want to answer it right now. I believe we're averaging the Q3 and the Q4 grades, so add them up, divide by 2. So if you have a 60% right now, you could get 100% on quarter 4, and that'll get to 80%. You'll get a B minus B. So you're going to be averaging what you have from one and the other. So if you have an A right now at 100%, if you don't sign in at all in distance learning, you can get 0% in quarter 4, and that'll give you 50% for the class. You failed. So just keep that in mind when it comes to your grade in general. It's going to be the average of the two more than likely. And here, I don't know how assessments versus homework's being broken down here, because this assessment is just a one-stop shot, no partial credit kind of question thing. It's weekly little quiz assessments. We'll probably go 50-50 this time around. This time, the homework and learning, it's kind of more on the important end of checking that out. All right, when is the next test and what will it be on? Now, this question was likely asked before I uploaded your assessment just the other day. So I'll let you know right now, it is online. If we go back to classwork here, find week 2, and at the bottom, you'll see week 2 distance learning assessment. What is it on? It's on the week 2 material. Complementary, supplementary angles, vertical angles, angles, parallel lines, and transversals. Now, I actually taught you most of what Khan probably taught you in this stuff in the how do we find the measure of an angle question. So you might know now how to do all these things based on it. And if we look at the assessment here, make sure you finish everything else. But if you look at the assessment, sorry, I'm going to steal a name here. Let's go 5th period and steal a name and type in an ID number. And then let's look at some of the questions. Complementary angle stuff here. Complementary angles without a visual. Supplementary without a visual. Vertical angles. Parallel lines cut by a transversal. I'll give you a hint. Those are alternate exterior angles. Go back to that part of the video to answer whether they're going to be equal to each other or supplementary to each other. Same side interior angles right here with parallel lines cut by transversal. And then a mixed review thing on inequalities, 2-step system on inequalities, much like equations, only make sure you know how open and closed circle works, which way the arrow goes. When you flip an inequality, make sure you know all of that information. I probably gave you a good opportunity to get an 8 out of 8 on that one right there as you see it. But it is online right now. I will have it up until next Thursday if you absolutely need that. It still might say due Tuesday. I'm going to change that because I uploaded it on Thursday. I needed to find out how, just to tell you, there was an assignment that we had a video for, but we didn't have an actual assignment thing for. So Math 1, when I say we, I mean Math 1. So we went through Khan and we found a proper one that applied to it. So we attached that later. That's why I didn't have an assessment up yet, because we were trying to find out how to quiz you on it. And, we wanted to quiz you on it, but we didn't have a practice thing for you yet. So we found it, and then I uploaded it. Okay, here we go. I don't really understand the Pythagorean theorem very much. Can you please do more in depth? I absolutely can. And it's interesting that you ask about Pythagorean theorem because I scrubbed through some of that Khan Academy video, and I can't guarantee that he ever actually said the words Pythagorean theorem. He might have, because again, I scrubbed through it. I didn't see the whole thing. But Pythagorean theorem, what does it have to do with for those who are not sure? Now, actually, I think this is week 1 material. I think it's based on week 1 material. But what we're talking about here, is finding the distance between 2 points. And I'm not going to do a full grid line thing here. I'm just going to give you 2 points right here and here, and you need to find the distance between them. And the distance between them is found by, again, Sal Khan might have used something called distance formula and used some variables. I'm going to use something more conventional with geometry and something that you'll be more familiar with, and it's called the Pythagorean theorem. And here's what the Pythagorean theorem states, and this is not just for distance between 2 points right now. I'm going to talk more about Pythagorean theorem than anything else. If you have sorry for the lines not being totally straight. If you have a right triangle, the sides of a right triangle have very specific names. They're called the two sides that make up the right angle. The shorter sides are called the legs. And then the longer side, opposite the right angle, is called the hypotenuse. This is true for every right triangle. There are no other triangles that have specific names of their sides. Otherwise, they're just called sides. Unless you say long side, short side. But these have specific names, the legs and the hypotenuse. Okay? Now, these legs don't have to be equal in length. I can't guarantee they are when I drew this. Sorry if they kind of look equal. But in a right triangle, there is a distinct relationship between the lengths of the legs and the length of the hypotenuse, and it is as such. I'm going to use letters this time instead of these names here, but let's assign lengths to the legs A and B, and let's assign a length to the hypotenuse C. There is a relationship in this such that if you take the sum of the squares of your legs, that will be equal to the square of your hypotenuse, or, to put it more simply, a squared plus b squared equals c squared. Okay. Now, I will do a single example with you because we haven't done square roots much together, and using square roots is a part of how you have to solve this stuff. And again, I think this is from week 1, but I still want to cover this. And actually, I'll use it with the distance thing. Now that we're talking about everything here, let's make up a problem out of a distance formula thing. Let's say that you have this point right here, and it's 2, 3, and then you have another point over here that is 12, 10. Okay, 2, 3, and 12, 10, and you're trying to find the length of this thing right here, this black line. Because remember, these blue lines didn't yet exist. I drew them in, but I'm actually going to redraw them in for a moment because we're going to use Pythagorean theorem to solve it. See, when we do our graphs, we can't count this way, like, oh, it's 1, 2, 3, 4. You can't count diagonally. You can only count vertically and horizontally. And you are allowed to count vertically and horizontally. Now, I don't have grid lines here, but I do have the point measurements. These aren't actual sides in itself, but if we picture them as just abstract lengths right here, we can go ahead and find the lengths vertically and horizontally by the distance between these points in a vertical and horizontal manner. See, the x's of these 2 points here are 2 and 12. That means it goes from 2 here to 12 here. And what I want to find right now is the distance between 2 and 12. I need 12 minus 2, that's 10. You could also count it if you have grid lines, but 2, you know that distance, that's 10 away. And then the distance from 3 to 10, right here, remember 3, these are for y, here's 3, and here's 10 for y, that distance, 10 minus 3, is 7. So you go 10 over, you go 7, it's like slope. You go 10 over, 7 up, or rise 7, run 10. But those are the distances. And if you equate this to a right triangle, these are the lengths of the legs of your right triangle, and we're essentially trying to find that hypotenuse, like that C. He might have used D, he might have used X, whatever in his video, he meaning Khan, he might have used those in the video. I'm just going to go ahead and use C and keep it in that form, because I can assign this as A and B and C, and we got to find out this length C. Okay, so in terms of understanding it, look, I'm not going to prove Pythagorean theorem to you. I don't think there's enough that you know in Math 1 to understand that proof just yet. You'd have to know the quadratic formula. You'd have to understand quadratics in order to make it work then. But hopefully you understand this process. I'm going to square 10, so I get 10 squared, plus, now I got to square 7. 7 squared equals C squared. 10 squared is 100, and 7 squared is 49. Equals C squared. So C squared equals 149. Now I didn't solve for C yet, I solved for C squared, and I now have to get C by itself. So here's where you use square roots. See, just like multiplication's inverse is division, and addition's inverse is subtraction, powers inverses are roots. So if you square something, if you want to get C by itself, you got to take the square root of both sides. And what's a square root? Again, it's the inverse of squaring. If 7 squared is 49, then the square root of 49 is 7. If 10 squared is 100, then the square root of 100 is 10. It's the number that you would multiply by itself to get the number that you have. So what number times itself is 149? Unfortunately, it's not what's called a perfect square. Say like the square root of 144 is 12, because 12 squared is 144. That would be a perfect, 144 is a perfect square. I can take the square root of it and get an integer. 149 is not a perfect square. 13 squared is 169. This is somewhere between 12 and 13. I'm not going to approximate it. We're not going to use a calculator for it. In the Khan Academy questions, they give you multiple choice option, and here we're just going to say C equals the square root of 149. Again, it's probably like 12.1 or 12.2 something. It's called an irrational value, but that's how I solve it. I use Pythagorean theorem, and then I take the square root of both sides to finish that problem off. If you follow the Khan Academy video, he probably has a lot more formula stuff where he's talking about how you got to do, 12 minus 2 and 10 minus 3. But if you have a drawn out version, or if you're just asking yourself what's the distance between 3 and 10, I think you'll figure it out a lot more easily. This is Pythagorean theorem right here, though, to answer your question in full. And I do believe this is a week 1 based topic, but alas, I wanted to make sure that I got it for you. Okay, that one's down, and I know I'm spending a lot of time for that. I know there probably aren't too many questions along the way after this that have to do with me doing too much. So let's go ahead and check them out. Let's see how many I have left. Just 4 more questions left. So here we go. Will we have to redo the Khan Academy assignments if we don't sign in? It depends if you have another way to provide proof for me that you did them. If If you can provide proof for me that you did something, then sure. If you do something, you find out you're not signed in, I guess the question is, and I think this was kind of asked the last week, but we didn't check, can we then sign in and will it give us credit? Let's investigate that together. Okay, let's check that out. This is your assessment. Let's close that one out. I don't want to do it for that student. So let's look at, let's see, complementary visual. Are these the practice ones right here? I don't want to see the names. Complementary exercises. So I already did these right here. And by the way, if you'll know if you did them if there's a nice check mark by them right here. So this is me having done them just to make sure I know how to do them there. I am signed in, Mr. Robinson. So I'm going to go ahead and sign out. I'm going to log out right here. And I don't want to do one of the ones I already did. I didn't do this one, practice identifying complementary, supplementary, and vertical angles, identifying which ones are which. I never did this one, so let's do the whole exercise and see. Relationship of A and B, those are complementary angles. They make a right angle pair right there. And then those are neither vertical, complementary, supplementary. Nope, none of the above. Let's keep going. Supplementary angles, they make a linear pair right there. So those add to 180 again. No, they also add to 90 or 180, and they're not opposite each other in vertical angle sense. And that looks like the same question as number one, so complementary one more time. Two more questions. That's a linear pair right there. Those are supplementary. And one more. Those are vertical angles right there, opposite each other. Okay, so I get my 7 out of 7. Awesome. And let's see what happens here. Let's see, because, let's see, I didn't get a check mark or anything yet. What if I get off this one here? Does it check mark me? So it check marked me for having finished it right here, but I'm not signed in. So at this point, you should really do something like your print screen button feature on your computer or take a picture with your phone, just in case. I don't know what happens if I close out of it. What I want to see is what happens if I log in. So I'm going to hit the login button right now. I'm going to continue with Google, and it's going to hopefully bring me to my... here you go, Mr. Robinson. And you can see right here, it is no longer check marked. So it does not account for the fact that I have done this problem. So this question is twofold here. Does it track your progress if you're not signed in? Doesn't look like it. It doesn't look like it. Do you have to redo it if you don't sign in? If you can provide me proof of having done it beforehand, then no. If you can't provide me proof, I guess you'll have to redo it. How long did that take me? 40 seconds? It depends on how much you have to do for the stuff, but it doesn't hurt to do more practice, really. And it's not too much practice, right? 4 questions, 7 for that. It's not too long. So if you understood how to do it, redoing it should be a cakewalk for you. So I'd say take pictures of things, and you can submit them to me if you found out you weren't signed in. Make sure you're signed in, all right? That's the end thing here. All right, next question. I'm not very comfortable with the way I learned about the Y's, so should I watch more videos? Oh boy, I don't know what the Y's mean. If you mean variables, we've had a lot of different things with variables. So, I mean, if you're not comfortable, should you watch more videos? Sure. Which videos do you watch? Whoever asks this, why don't you go and email me and ask me what you're talking about specifically? If you're talking about angles, because, maybe you don't know a symbol for angles. Let me give you the symbol for angles here. It looks like, well, it doesn't look exactly like that. That's the less than sign, but it's kind of like that. You've probably seen the angle symbol before. So if you're trying to say angles, I would write it out. For Y's, I would say variables. So be very specific when you're talking about that. If you're talking about applied math, you're in my applied math class systems of equations, maybe watch more videos, I guess. But email me if you ask that question, what you're specifically talking about, and I can help you find videos. I might even have videos that I have already made. And of course, you can join me on Zoom to ask me other questions, and we can get direct one-on-one instruction and attention. So make sure you do that. All right, that one's out of the way here. Next question is, how long is this online school going to last for? I'm going to make the end all, because now it's May 1st, and this was when they announced that school's closed till. It's either they've already made the announcement that school's closed all year, I don't know, or they're going to announce it today or this weekend or whatever. Make the assumption right now, school is closed the entirety of the year. We're going to be online for the rest of this year until May, whatever. Let's check our dates here. Until May 29th, I'd say. So it's going to last the rest of this school year. Let's just make that blanket statement and say that, right? We have to do enough to not be in large crowded spaces. We have to keep our social distancing apart. If you're talking about summer school, I can imagine that we're going to be there for summer school as well. We got to see if the summer can kill off the virus and do things like that. As far as next fall, again, hope for the best, plan for the worst. And if your hope is to not have distance learning afterward, my hope is to not have it afterward. Hope for that best, plan for the worst. We could have it. So how long is it going to last for? Could last to the start of next year, guys. We could be starting this next year. So it's a good time that we get this out of the way, squared away, making sure you know how these 6 weeks work. And then you go from there. The real scary question, because the scary question here is, what's this end game? Where's the finish line here? I don't know when this whole thing is going to end, right? When can we be as we were again and all be in a crowded basketball stadium together and be teaching normally? I don't know. But you can imagine that as long as we're having enough closures, that we'll be doing distance learning. So how long is it going to last for in general? It could be a while. I don't want to make any guesses that sound outlandish, but you got to plan for the worst. So if we're till October, if we're till next March, I don't know. It's a scary thing. It's a scary thing here. That's why I like to have a lot more videos and more personal stuff with you guys, because just sticking you to Khan Academy stuff's not very easy for you guys. I understand that. It's really scary for all of us. All right, last question here. This is not math related really, but do you think it's best if we take as much notes as possible to prep for the final? Well, it's math class related. It's content, I guess it's not. But, I don't believe we're having a final. I think we're just going through week by week and bit by bit. So as far as cumulative assessment, there's nothing necessarily, except for as you see, your assessment for week 2 has the inequality stuff. You always get some mixed review. So you're going to get mixed review for week 3, but you'll be given review videos for it to practice with as well. So no cumulative final. So unlike, there would have been if we were still in class and we didn't have 5 weeks off and stuff like that. There would have been. But I think that last week you're learning more material and you're being assessed just like these other weeks, week 6 or 7 or whichever one it's going to be. So I don't think you have a final. As far as notes, it doesn't hurt to have something on record for going into your next math year. Okay? It doesn't hurt to do notes. If you feel like you're acquiring the knowledge though and information to do stuff, I think you're fine. It is a very good question. No final. It's all based. This is what you see this week and what you saw last week is what you're going to see the final week of the school year. All right, so I hope that addresses it, and that ought to do it for this one, guys. This is Mr. Robinson. I got to go ahead and do an applied math Q&A. You can see this one online by end of day today, Friday, as long as YouTube is not being a butt like it was last time. All right, guys, so take care. Hope you enjoyed this one. Have a good one.